Hi everyone. In this video we are going to solve a Singapore secondary school mathematics Olympiad in 2003. So the question is, let x be a real number and let a equal to this expression. Alright. So they are asking that prove that a is an integer and find the unit digit of a to the power 2003. First, we have to prove that a is an integer. Then we have to find the last unit digit of that integer. So, as we can see, we have a equal to this expression. Then, if this expression can be an integer, we have to consider the conditional of this expression. I want you to see this fraction. So as we can see, the numerators, the number under the square root must be greater or equal to 0. Okay, so these two numbers under the square root must be greater or equal to 0. So the conditional ones must be like this. Alright, so conditional ones we considered to the numerators, and the second conditional we consider to the denominator here. So now look at the first conditional. We have the number under the square root must be greater or equal to 0. Alright, so it's implied that the absolute values of x must be greater or equal to 2, and here's implied that the values of the absolute values of x less or equal to 2, and that implies that the absolute values of x must be equal to 2. So the answer for x equal to plus or minus 2. Alright, now we got one conditional. So the second conditional must be like this. Okay, since the denominator here is not equal to 0, it implies that x is not equal to 2. Yeah, so by following the first conditional, which is x equal to plus or minus 2, and the second conditional, x is not equal to 2. So for the first conditional and the second conditional, finally we got that x is equal to minus 2. Okay, so we will take x equal to minus 2, substitute into a here. So the expression a, which is a equal to, so we have here, which is the expression here, and we substitute the values of x equal to minus 2 into this fraction. So then that will be minus 2, and here's also minus 2, and here's also minus 2, minus 2. So minus and minus sign will be plus, so that will be plus 2. So we calculate the values for these expressions. Minus 1 plus sign and minus sign will be minus, so that will be minus 1 and minus 6. Alright, so plus and minus sign will be minus sign, that will be 1 minus 2. Okay, so here's absolute values of minus 2 will be equal to 2. So 2 minus 2 equal to 0. And then 2 minus 2 equal to 0. So the numerator here is equal to 0. So that will be minus 0 divided by 4. Okay, that will be equal to minus 7 divided by minus 1, and then here's 0 divided by 4 equal to 0. Okay, so the answer must be equal to 7. Okay, finally we got that a equal to 7 is an integer. That is true, right? So they want us to prove that a is an integer. Now a equal to 7 is an integer. That is true. Alright, now for the final questions, we have to find the unit digits of a to the power 2003. As we can see, now we got the answer for a equal to 7. Then a to the power 2003 equal to 7 to the power 2003. So we have to find the unit digits of 7 to the power 2003. We can write that 7 to the power 2003 equal to 7 to the power 2000, and then times with 7 cube. So then 7 to the power 2000 can be written as 7 to the power 4 all raised to the power 500, and then times with 7 cube. Alright, then that equivalent to 243, and then 243 equivalent to 3, which is mod 10, right? That means 243 divided by 10 will be remainder 3. Okay, so that means the unit digit of 7 to the power 2003, which is 3. Therefore, the unit digits of a to the power 2003 is 3. Okay, that is the final answers. And thank you for watching. Please subscribe my YouTube channel. Goodbye.